Hello guys, welcome to my channel Tech Attack, and in this video I'm going to give you a brief introduction about machine learning. So I prepared this notebook to help me in this video because when I'm making a video I get a little clumsy, so I think I will just read it out for you. If you want, you can download the whole thing. I will link it in the description below, so you can follow the description to get that notebook. Sorry. So without further ado, let's get started. So machine learning is a process where the machine figures out the optimum model to solve a solution by itself. So let's take a typical scenario where we have to predict or calculate something based on other parameters. For example, predicting the distance traveled by a car by knowing its average speed and time, and predicting the future temperature based on current temperature, time, and season, predicting the rise and fall of a share market, etc. So these are the scenario where we have to predict or calculate something based on other parameters. Now the basic structure of machine learning algorithm in general are three: modeling, training, and predicting. So whatever the goal is, it's better to start off from the very beginning of the whole journey. So we start from solving the most simple problem requiring the least knowledge possible. Let's say that we have to calculate the distance covered by a car in a given time with constant speed as kilometer per second traveling a straight road. To calculate the distance covered, we have to multiply the time with speed and we'll get the distance. So this simple thing can be written as a formula which can also be recognized as the optimum model for the solution. So basically model is simple as the distance is a linear function of speed and time. Now um, let's spice things up a bit and look for more complicated situation. Let's take an example where the speed of car is a function of time and remaining distance between the car and the destination. Okay, the speed of car is a function of time and remaining distance between the car and the destination. So in this situation, there is a bit of ambiguity in the relation between the speed of car and other parameters like time and remaining distance. To cover up the ambiguity, we have to assume another parameter which controls the amount of factor which each parameter contributes individually to the key parameter, that is the speed of the car. Those parameters are called weights. They are multiplied with the respective parameters and added together to get a final prediction about the key parameter. So far we have formed the equation to predict the speed of car as S equals Tw1 plus Uw2, where speed of the car is S, time is T, and remaining distance is U. W1 and W2 are weights. Now, it is likely that there could be some off values regulating the speed along with the time and remaining distance. To counter that likelihood, we can assume another parameter called bias, which we will add with the output. The resulting equation would become like S equals Tw1 plus Uw2 plus B1, where B1 is bias. This building of equation concludes the modeling part of machine learning. Now the remaining challenge is to find the value of the tunable parameters W1, W2 and B1 such that we get the output as close as possible to the real value. This searching of fundamental part of machine learning is called training of the model. Once trained successfully, we can predict the output of a given parameter. The most important part of training a model is to figure out a way to rate the performance or accuracy of the model. This can be done either by using a loss function or a reward-based scoring function or a fitness-based scoring system. Selecting a proper loss function is crucial to perform a proper training. The loss function is a measure of how off the mark the current model can predict based on its weight and um, based on its weights and biases are adjusted to get the lowest possible value from the loss function. In a way, the loss function maps the weight and bias with output and thus makes them trackable. By trackable, it means that the ratio of change in weight with respect to the change in output can be calculated. This ratio is called gradient, and this tracking back of gradient using loss function is called backpropagation. By now it is clear that the gradient contains the information related to how the change of parameter will affect the output and loss function. The next step is applying the gradient in some way to update the model parameters to actually lower the loss function. The process of applying it is called optimization. Although the process of training the model seems quite fair, but with big data comes big responsibility. Big data is nothing but a large amount of data, and as the word big is not well defined, so the big data is also not well defined. Though the optimization process has been mentioned above very fairly, but it would be an understatement to say that it would go without concerning for big data. It should be considered that optimization is not for a single data point only, but has to be considered for every data points in the dataset. The loss function is responsible for accounting all the data points in the dataset. It ensures that the uploaded value is in good terms for all the data points. This means the loss data this means the loss function has to be calculated using the bundle of data. This can cause a probable issue for big data, as calculating the loss function for such a massive amount of data would eat up a massive amount of memory and the software could crash due to that. And even if it doesn't crash, it would cause performance issue as calculating it will require a considerable amount of time and processing power. This troublesome situation mentioned earlier can be avoided easily by segmenting the big data into smaller chunks called batches. This process of breaking it down is called batching. In situations where multiple tunable parameters to provide optimum solution, there is always a chance for having a multiple optimization configuration. This may interfere the optimization process as the uploaded parameter could dangle between those points, as there is a chance that the model parameters values are being updated independently from the other parameters. As a result of this race condition, certain instability would occur. For example, say we have the equation x plus y equals 5 with initial value as x equals 3 and y equals 3. Now the goal of the optimizer here would be to make the output of the equation to be equal to 5. So either x equals 2 and y equals 3 or x equals 3 and y equals 2 could optimize the problem, as they are being updated individually. So the optimizer would attempt to update the value of x as x equals 2, as it won't consider a change in the value of y while tracking the gradient. Same goes for y. Learning rate. In a situation where there are multiple tunable parameters to provide optimum solution, there is always a chance for having a multiple optimum configuration. This may interfere the optimization process, as the updated parameters could tangle between those points, as there is a chance that the model parameter values are being updated independently from other parameters. As a result of this race condition, certain instability could occur. For example, say we have an equation x plus y equals 5 with initial value as x equals 3 and y equals 3. Now the goal of the optimizer here would be to make the output of the equation to be equal to 5. So either x equals 2 and y equals 3 or x equals 3 and y equals 2 could optimize the problem, as they are being updated individually. So the optimizer would attempt to update the value of x as x equals 2, as it won't consider change in the value of y while tracing the gradient. Same goes for y. So finally they both update their values as x equals 2 and y equals 2. So the optimizer would iterate again and it will change the value back to x equals 3 considering y equals 2, but again y will update itself as y equals 3, consider x equals 2. In short, they are not aware of their possible updates and thus ends up dangling between x equals 3, y equals 3 and x equals 2, y equals 2, and thus never gets optimized properly. To solve this instability of rapidly changing parameters, the update speed is regulated by using a factor called learning rate. It means that if the learning rate is 0.1 and the optimizer wants to update the value of x from x equals 3 to x equals 2, the optimizer will calculate the change as dx equals -1 and then will take a portion of the update by multiplying it with learning rate, then adding that portion to the parameter as an update. So new value of x equals previous value of x plus dx multiplied with learning rate. Therefore, if the optimizer wants to update the value of x from x equals 3 to x equals 2, the with learning rate of 0.1, the optimizer will update it to x equals 3 plus uh, negative 10.1, which would evaluate to 2.9, and y would be 2.9. So the next update of x will be aware that the value of y is not 3 but 2.9 and thus require x equals 2.1. So the new x would be 2.9 plus negative zero point 0.8, which would be 2.82. Similarly, y equals 2.89, and gradually after several iterations later they will come close to x equals 2.5 and y equals 2.5, and this continues and this concludes the concept of learning rate. Running through the database once might not completely optimize the network at satisfactory levels, as training the model is a gradual process and requires a lot of time. The repeated running through the same database again and again is backed by a term of epoch. An epoch gives the measure of times the optimizer runs through the same database. The most bizarre thing about living organisms is that they show intelligent behavior. Intelligent beings like humans can behave intelligently because of the presence of nerve cells present in the body. Once upon a time, the working of a nerve cell are observed by a researcher and imitated over simulation software which showed promising results. This simulation was intended to study about it, but fortunately that model turned out to possess a greater computational power than traditional machine learning approach. That discovery became revolutionary and learning, stepped up the power of machine learning. Artificial neural network gave us the idea of a powerful model which when used can be powerful enough to solve real life complicated problems that traditional machine learning approaches fail to address. In short, ANN is nothing but the concept of a powerful model which is also being used by us human brains. A neural network can be represented by a network of interconnected nodes. Each node has its own individual parameters and thus have a potential to create some form of individuality in the whole network. These individual parameters are generally simulated using activation functions and bias. A bias is added to the input signal and then activation function is applied to it to transform the input signal. The individual parameters are responsible for transforming and translating the input signal to provide its own individual response to it and pass it forward in the network. The nonlinearity of an individual perceptron can be simulated using nonlinear function called activation function. This nonlinearity plays an important role in solving complicated problems as most of the real-life challenges are nonlinear. Some of the common activation functions are linear activation function, sigmoid activation function, ReLU, leaky ReLU, softmax. A single perceptron is practically not feasible for real-life use cases. Many perceptrons participate in tandem to perform this big task. They, the topology they are connected plays a vital role in their functionality and performance. The arrangement of typical artificial neural network can be described using neurons in layers and their type of connection. Multiple perceptrons arranged in parallel to receive from the same input as a layer. To receive from the same input forms a layer. Layers usually takes data from the previous layer. In a layer, each perceptron has their individual parameter to decide how much portion of the individual input data to receive, and this parameter is called weight. The network starts from input data and therefore inputs are treated as perceptron forwarding the data in the network, also called input layer. The endpoint of the network is observed and treated as output and thus called input layer. Anything in between is called the hidden layer. The size of an input layer and output layer can be resolved easily because they have to be of the same size and the provided input and the required output. But the size and number of layers in between them is not bounded and can have any size and number, thus cannot be guessed factually. As they are hidden until explicitly looked upon, such layers are given the recognition as hidden layers. The main objective of the hidden layer is to provide assistance to the network in solving fairly complicated problems by adding more nonlinearity to the model. It's a good practice to keep the model small and as simple as possible, but this comes with a disadvantage, as it can only solve a particular problem and fails to generalize approach. To build a generalized model which has the ability to solve problems of various fields, it becomes mandatory to add a lot of hidden layers to the network. Such big models with high computational requirement is recognized as deep neural network. Lately, a lot of researchers becomes a fan of artificial neural network and thus contributed a lot of models with exponential real-life use cases. The secret ingredient to this spatial model is the model structure. All the concept mentioned above is related to artificial neural network, but this approach is just one of many available approaches. Machine learning models comes in various shapes and sizes and have a lot of fundamental differences among each other. As a machine learning engineer, the difference will have a huge impact on the success rate and convenience of any project taken. Based on the training approach taken, machine learning algorithm can be classified into three categories: supervised learning, unsupervised learning, reinforcement learning. Based on the type of problem space, machine learning algorithm can also be classified as regression based or classification based. That's it for this video. Thank you for watching. See you next time. Bye.